So good afternoon, and happy to meet you again on the webinar. So today we just try to introduce some aspects of machine learning. So it's just introduction, and then we try to give some example and case study. So let's start. Machine learning. So what is the definition of the right learning? According to Simon, learning is any process by which a system improves performance from experience. And this is exactly. Usually if we want to learn something, we need to learn from our mistakes. So we need to do experience, and from the experience we can improve our quality, we improve ourselves. So the same thing, we will use it for the machine. So there is two main tasks, if we can split it in two categories. There is classifications, and we have problem solving and control planification. So for classification, we have a lot of things. We need to assign object or event or any input to one of your categories. For example, medical diagnosis. I will give you later on case study, credit card application, fraud detection, spam filtering, finance, DNA, handwriting letters, and so on. There's a lot of application in order to make our system able to make the difference between different categories. The second one is problem solving. Maybe you can use it for calculus, how to solve problems in calculus, how to do a balancing, how to drive a car, controlling elevator, and so on. And for the most example one is for mobile robots. So if we have our classification, we need to measure our system of our software performance. We need to use classification accuracy. We need to use the solution correctness. Is the solution correct? Is it good approximation or not? The quality of the solution and the speed. Is my software, is it fast or slow to take decisions? So we study machine learning, and here is extremely important. If you want, for example, to solve the system, and the system sometimes is extremely difficult, extremely expensive for engineering to do it. So we need to use computing system to solve the problem. Develop a system that can automatically adapt themselves to individual users. For example, your email, your computer, your browser emails, and so on. Discover new knowledge from a large database. We need to get some properties, some output from a huge database, and this application is extremely huge in the industry. So why we study machine learning too is one of the main aspects is to study and to understand the brain of the human, how it works, how to understand the biology, for example, here. So definition of the learning task. Let's take the second examples here. So what we want our system to do something. So we call it task. For example, here, recognizing handwriting words. So I'll use this example along my presentation. P, I want to measure if the system is it good. How? By calculating the accuracy rate, the percentage of words was correctly classified. If it's high percentage, means my software is good. We need to teach our system. How to teach our system? We need to create or to have database of human handwriting in order to teach the system. If you see this image, this is most likely to be A or to be C, and so on. Take example here. One of the motivation problems we need to do handwriting characters. For example, here we need to do this database. The first row, for example, is many different ways how to write two, and at the end I need to tell my system that all the first row is the character number 2, second row is character number 3, and so on. Or we can use Chinese letter, or Japanese letter, or Greek letters, and so on. Another motivation is the building access by using fingerprint, and it's extremely useful for the laptop, for your building, for security system, for banks, and so on. Or we can use face recognition for security system, for example, or emotional faces for the medical field. Or we can use the detection of your age just from your face. So can machine learn to solve this problem? Or another questions in another way. Can we program machines to learn to do those tasks? And the answer is yes. Let's start the definition. So computer programming is said to learn from experience. You see here we said to learn from experience with respect to some task, because I'm waiting for my software to do something, to do some task, and I need to measure the performance of my system by parameter P. For example, what is the rate, accuracy rate, what is the exactness of the solution, and so on. How to measure it, how to compare between two different systems, which one is better. So we need to introduce the performance measure. So what does this mean exactly? For example, here, take the handwriting recognition problems. So the task T, what I want to recognizing all the handwriting. And I want to measure it. How to measure it is by percent of characters correctly classified. And we need to give the database to our system, so we need to do the training experience, we call it E, in order to teach our system. This is example. For example, this is all handwriting for letters, for numbers, capital, small letter, and so on. And we want our system to be able to recognize every character correctly, or the most correctly possible. For example here, let's look to our system until now as a black box. This is learning system. I put the input, for example here, the small circle, it looks like Z for me, but I want my system to give me the right recognition, which is Z. So we need to collect training example. So we need to do, for example, 2, 2, 2 many times, and we need to tell the system this is number 2. For 3, we need to write it by a different way, or maybe by different peoples, and we need to tell the system that is number 3. So we call it supervised learning. So I need to tell the information to my computer in order to catch all those information that we use it later on. So for example, if you have the character 5, we have the character 8, how to give this information to the system? So we need to make it as digits or as numbers. So take example here, just example way, but we can use a feature selection in many different ways. We can use cosine transformation, we can use Fourier transformation, we can use wavelet, curvelet, a lot of things. But just try to take small examples. Here we have the number 5, and the intersection with the grid lines, horizontal and vertical. If there is intersection, we put 1. If there is no intersection, we put 0. So at the end, for example, we can get 64-digit vector, and this we call it feature vectors. So from the input, I will get some features to make me, or to help the system to make the difference between different characters. We have 8, we can get different vector, of course, in order the features vector or feature selection to be correct. So for 5 and 8, we need to have 2 different vectors. So let's call the vector a feature vector of x1 until xn, and its size of features. So we need to get the right size in order to get the best performance. So we need to represent each experience with vector x. Later on, I need to tell my system. So we need a corresponding vector d. What is d? D tells me exactly what is the character x. I give this information to the machine. So the experience will be a pair of vectors, the vector x, which is intersection or feature selection, and d give me exactly what is the character. So what we want to do, we want d be like, for example, this example here. Let example, if I want to, my system is only 10 images or 10 characters. So we want to do 10 digits. D0, D1 until D9. If X is digit 5, so D0, D1, D2, D3 are all equals to 0, except D5 equals to 1. And the same thing for D6, D7, D8, D9 are equals to 0. In order, just if you have this picture, so my system knows that this is the character 5. The same thing for 9, everything 0 except the last one, D9 equals to 1. So the computer will be able to understand the character x or the features vector x correspond to the digit 9. Okay? So for 5, we have this x, the feature selection. We have D is only the D5 equals to 1. For 8, we have this another feature selections or feature vectors, and we have D, which is different to the previous one. Here 1 is at the position 8. So what we want to do now, in order to do the classification or the learning system, we need to find a function capital F to approximate our block or the black box. So our input will be X. This is our learning data. Our output will be the function capital F, but the function capital F should be equals to D in middle. But usually any function has parameters, and we need to play on this parameter in order to increase the performance of our system. So the E, this is our experience, is X and D. Our function, we need to build our function to be exactly equals to D. So, but this is not always the case, so we need to put our database, we need to put our function with different weights or different parameters. We need to calculate the output, and we need to calculate the error, because we know W, we know D, so we can easily calculate the difference. When the difference is the smallest, I will keep all the parameters of my system, and this will be the best functions. And later on, this I used only the learning data, but in order to test my system, I need to use another data which is not being used in the learning step. For example, here we get all the parameter W. We need to do a new character. For example, here we know it's 3, and we want to check what is the answer of our system. And based on the new testing data, we can calculate the performance of our system. So just give you an idea about the features, how to get the features. For example, here I have a lot of ellipses, and here ellipses I want to classify them to 3 categories: the big one, the small one, and the medium one. So according to us, what is the best features in order to do those classifications? So here we can measure the major axis and the minor axis. X1 is the major, X2 is the minor. The two values can be the best features in order to make a huge difference between different classes, or to do the segregation between different classes. So for each ellipse, it will be represented by X1 and X2, means is 1 point. And if we gather all the features of the same graph, we can see the blue one is the biggest, the black one is the smallest, and these are the medium. So the features are exactly suitable for the classification in this target to say the ellipse is big or small or medium. Okay, let's go now to the case study. This is exactly what I'm doing as research now in the medical field, but we can apply it to oil and gas application. We can apply it to the other field, even for the banking estimation. So the case study here is we are doing development of computer-aided system for cancer diagnosis using some mathematics advance in order to do the diagnostic or the early detection for breast and lung cancer. So we talk here, for example, the cancer is a disease which is considered as one of the main causes of mortality. So why we need a computer to help doctors to do the right diagnosis. And this is just some statistics in the world about the cancer. It's caused by the lifestyles of people and usually affect all the human body, could be anywhere. So in 2008, reported 7.6 million people passed away in the world. 70% of those live in the low and the middle income countries. The common type of cancer is the lung and the breast. Lung mainly for male people, and breast cancer is for female. So the high percentage in this country could be due to the low quality of the health. So we need to do the early detection or early diagnosis in order to prevent some life. So the breast cancer is the one of the most leading causes of death And here, this you can see how it is extremely high, the breast cancer for females. And for the lung cancer is huge, and the main cause of the lung is smoking. Take advice, stop the smoke right now. So, usually the doctors, what they do the screening, they do the diagnosis, treatment, and then follow up. So why it's extremely important to do the early detection. So what we want to do here, we want to get our image, could be mammogram, could be CT scans, could be any type of image, medical images. So we need to do the image reprocessing, filtering, removing the noise, segmentation, feature extraction, and classification, and our result. So we have a lot of issues here. Some radiologists pay no attention to detect cancer because there is a lack of trust between the computer system and the radiologist. Cancer cells, abnormality in the images could be very subtle, extremely small, so it cannot be detected by a human being. So we need computer to help us. The high false positive. False positive, what does it mean? The system gives you that you are sick, but the real reality you are not. We call it false positive. Or we call it the false negative too. So we need to enhance our system. So this all will be our research questions. How to enhance the system, how to increase the accuracy, how to reduce the number of false negative and false positive and false negative. So the aim of this research is to develop a computer-aided system for cancer diagnosis to investigate the use of multi-resolution methods, how to do the feature selections, to reduce it, to compress it, which method is the best one to detect the suspicious lesion, and our diagnosis, of course, at the end. So this is our system. How we do it? We need to read all the literature review, all the system existing, to think how to improve it, and so on. So we have image. We need to do the detections of the suspicious lesion. We need to classify them and do the right diagnosis. So for example here, I give you all the interest region of the cancer. Here we do it manually. We crop all the images by helping by the doctors. From here we can calculate the template of this cancer. We need to do some mathematics models to build it. We will explain it later on during the course. And here I'm just giving a brief introduction only. So just here we can use chi-square. These all are new parameters we developed just 6 months ago. And we need to do the sum square in order to detect only the minimum locus. And all the minimum locus are the suspected region to be a cancer area. And later on we can do the classification. And the same idea, we can use it for face detection. Look, for example, here we have 2 images. One is outdoor and one is indoor. When we do some mathematical models, we can find a lot of minimum locus, and each minimum locus gives me the most likely to be a face. As you can see here, the cropping, we have a lot of squares. And later on, we need to do some diagnosis or some classification in order to say, is it face or not? But for the cancer, we can say, is it cancer or not? Is it normal or abnormal region? Okay? So this is just a system of classification for face detections. And this is our target. We have database. We need to split it in 2 parts. One part is for training, to teach my system. And the second one is for testing, to test my system. Is it correct? Is it reliable? Is it accurate? Is it, and so on. Later on, we need to do the diagnosis. And the diagnosis, we need to measure the response system. For example, if I ask you a question and you give me answer, and your friend maybe asks you, how sure are you about your answer? So we need to measure the exactness of the response of the system in order, do I need to trust the system or not? If not, I need to do rescreening the image again. Pre-processing in order to remove the noise, in order to make our image visible to the computer. And this is something how to do the histogram equalization. And this, look here, you see the 3 images are extremely different in order to make it easy to computer to understand different classes. Here we can use wavelet and curvelet to do the feature selections. And later on, when we do those here, and usually the wavelet and curvelets give me a huge number of features. So I need to compress it to the small by using some statistical metric, statistical energy to reduce it. And we can use Gaussian or multi-Gaussian vector to calculate the overlapping in order to say this feature is it suitable for classification or not. So don't worry about all those calculations. Later on we need to study it one by one, and you will see it will be extremely easy if we understand our target, if we understand where we are doing to. This is my software that I developed 2 or 3 years ago. This is the most accurate classifier, cluster KNN classifier. And this is just to give you an idea, but we will use many algorithms of clustering, and this will be our part of our programs. So I try to go faster, so later on we will go details. The target here is just to understand some application of machine learning. And this will increase our accuracy to 97.75 of accurate, which is extremely high result. But we still have 3% of false negative and false positive. And this is our image, how to do the right localization of the region of the cancer. And we can use scan images, and the result was extremely perfect, 100%. And this is for the lung cancer detection. We can use mammogram images. We can find all the suspected region. We can find 5 or 6, 7, but later on we need to get just the right one. So we need to change our sample size. Of course, the same idea of the wavelet. I don't know if you are familiar with wavelet and curvelet transformations. So the system should be tested by using, this is the MSIT-SE database. It's a very common database. So if anyone develop a new algorithm, need to test his algorithm or his approaches by using the same databases in order to compare with other works or previous works. And here again the result was extremely high, and this here when we use the 6th time. So if we do the classification, you are sick or not, later on if you have cancer, I need to say which cancer is, and here maybe you have 6 or 7 type of breast cancer, and the accuracy was very low, 74%. So the question here, how to improve it? So the idea is here comes for the tree classification, that we will do it again during this course again, and we will explain step by step how to do it. And here also how to compare our result with the previous literature review, and we can see that our algorithm was significantly better than the others. And here we can use X-ray images too, and the result it was almost perfect again. And we can use benign, malign. There's 2 types of cancer, benign and malign. One is dangerous, the other one is not. And we can use CT scan here for the images too. We do the normal, abnormal, and there's a lot here. I try to go faster, and here we need to get, when we do the feature selection, what is the number or what is the optimal features that give me the high accuracy. And here we need to do the graphing in order to locate the best or the optimal parameter here. So this is our system. We can use the curvelet in order to use the wavelet, or we can use auto transformation to check which one is the best. So I try to go faster to just see the result, and later on if you want I can send you this presentation. So just contact Vika and I can give you all those files. And this is our last research topics about the feature selections or the feature extraction. Usually all the people what they do until now is to measure each feature alone, and here is extremely not accurate. So the future work is how to measure the multivariate features at the same time, and here we can improve our accuracy significantly. And here just some statisticals how to measure things. I just give you an idea. What sometimes we need probability and statistics tools in order to solve some calculations problems, the target, okay? And calculus 2, calculus 1, this is of course is a must. But before starting machine learning, I will give you a brief introduction about mathematics. Okay? So I think I run at the end. So please let me know if you have anything, any questions, or if you want me to re-explain some slides, I would be happy to. Thank you, Vika.
Thanks a lot, Professor Belhauari, for a very informative presentation. Now it's time for your questions, guys. I will repeat the procedure again. If you have any questions, please type them in the questions box. So I'll see the question and I'll read it to Professor Belhauari, and he'll answer it. Okay, we received the first question. Very good. It's from Dmitry Kustersky. Okay, so he wants to know, what books can you advise about machine learning for beginners, and what areas of math are required for studying machine learning? So what mathematical knowledge should you have to study machine learning? And
yes, exactly.
Yeah, what books can you advise?
To answer the questions, so to answer the questions here, I have this is the course description for the machine learning, and here all the requirements here. So the requirements background is basic probability theory and linear algebra 2, and little bit familiarized with programming by C or C++ or any other language. It doesn't matter at all, or you can use MATLAB to make it easy for you. And the books here, to be honest, I'm using two books. This one here, pattern recognition and machine learning. I think it's the most nice approach to the machine learning. And there is other extra books that can use it. Is Russell is very famous. And I think during our course, I think the presentation or all the PowerPoints or all the lectures not will be enough. And we use the books is just to be as guide for us. But I think during our classes, when we do tutorials, we do some labs in order to enhance the learning process. But mainly I will use this book of course. So learning is the probability is important in order to understand some topics, and a little bit about linear algebra. So that's all. Yes, it was a very good question.
Okay, thanks a lot, Professor Belhauari. Well, I'm sure we can send Dmitry a list of books, right? If you share them with me, Professor Belhauari, I'll send the list of books you recommend for reading to Dmitry Kustersky later.
Yeah, of course.
Okay, great. And here's another question from Alexander Krivosheyev. Where can I download presentation? Okay, from lecture. So actually, Alexander, I can answer your question. The recording of this webinar will be posted on the internet. So you'll find it on YouTube, where you can download it. And you will also find all the necessary information in social networks, such as VK and Facebook. Okay? So, and Professor Belhauari can also send me his presentation, and I'll forward it to you. Is it possible, Professor Belhauari?
Yeah, of course, yeah. Definitely, yeah.
Great. Okay, we are receiving a lot of questions. So, and here's another question from Mansour Hazaev. So he asks the following thing. As I understand, the main idea is to make machine to learn without being explicitly programmed through generalization, right?
Yes, exactly. Yeah, exactly.
Mm-hmm. The next.
So the idea behind is we need to build a mathematical model in order to get the best feature to make easy the learning process to the machine. Yes.
Thank you. And the next question from Maxim Kazakov. So he says the following. You have mentioned several subjects which are required before starting to study machine learning, but maybe you can recommend subjects to study along with or even after machine learning classes.
Yes, so I think the machine learning here, my presentation, it was a little bit advanced, but later on when we start the course, we go step by step. And to be honest with you, it's just there is some philosophy concept that you need to understand, and later on it will be extremely easy. So don't worry, I think what you need until now is just you need to do a little bit about probability, a little bit about learning, about linear algebra, and how to do a programming, just as beginning. And later on, we will go together step by step, and we need to do some office hours to explain more the ideas. But to be honest with you, I think machine learning is extremely easy and difficult at the same time, if you don't understand the concept or the philosophy, what you are looking for. Yes.
Okay, thanks a lot for your answer. And the next question is from Anton Ivanov. Are you using some open source, for example, OpenCV library?
Yes, OpenCV, I have. Is it according to my CV, right?
Well, I think so. Yeah, the question was about the open source. Do you use any open source? So maybe where Anton can find your CV.
Yeah, open source.
Yeah. So, okay.
Yeah, this open source I have. I think you just Google my name, you'll find it easily.
All right. So the next question is from Oleg Iskra. So what about the skin cancer? Its mortality rate is less than the rates of the most dangerous types of cancer, but it also is the most suitable for machine detection according to its visual symptoms. So.
Yes, exactly. I have some colleagues and they are working on it in order to do segmentation and classification of the skin cancer. It's extremely important, yeah. But here, all my case study can be applicable to other different of cancer. So it will be our new project next year. It will be multi-cancer early detection and diagnosis. So it will be multi-cancer, not only for lung and breast cancer. We can make it more general. Yes.
Okay, thank you. So the next question is from Dmitry Kostersky. So how is unsupervised learning? How does unsupervised learning work? How does it work, unsupervised learning?
Exactly, extremely good questions, yeah. I think the unsupervised learning is we don't have any idea about it. It's black box, so we need to do the classification, or the clustering, sorry, the clustering, the right word is clustering. For example here, so how many classes do we have? This first question. And if we know the number of different classes or subclasses, how to make the difference between them. So from here we can use the notion of the probability, how different sources are, and how to make or how to segregate the different sources. So we can use the most common algorithm is the K-means cluster. But the K-means cluster suffers by two drawbacks. What is the number of classes and how to get the minimum global, but not minimum local. And this is my research topics too, and I'm finding to get the global minimum, we get it, but only for two clusters. If you have more than that, it's still open problem until now. So later on, maybe I'm looking for master and PhD student to work on this topic. So it's extremely good question here. Thank you.
Thanks, Professor Belhauari. The next question is about actually breadth of learning. How does machine define the breadth of learning, like the limits of learning, maybe, the borders of learning?
The border of learning, yeah, exactly, yeah. So how to make the difference between 2 or 3 software? Which one is the best? Which one the border of the learning? So the best system is the one who gives me the high impulse, high quality, and need few or medium data set. It doesn't need a lot of databases, because some software need a huge database in order to be able to make the task that we ask for. But the best classification or the best machine learning is the ones who need a little bit of teaching, little bit of time, and little bit timing for learning and time for giving the response. Yes.
Okay, thanks.
Thank you.
So the next question is about, again, machine learning. Is there any way to not only make machine learn how to do a task, but also to define this task?
To define the task, exactly, yeah. This is also to be learning, because I want to define a task, so I need to teach my system, if you are in this type of situation, you need to take this decision. So this is, again, will be included in the experience. So the system is not, the machine cannot think alone. So the difference between human being and the difference between the machine learning, that we are taking decision, but the machine is choosing a decision. And there is a huge difference between take decision and choose decision. Choose decision means I give the system many choices, and he needs to choose the best one according to some improvement made. Yes, extremely good question. Yeah.
Thanks a lot, Professor. The next question is from Mansour Haziv again. So do you think generalization of mined data, I think it's mining data, right? Do you think generalization of mining data is enough for creating an artificial intelligence?
I think is a part of it, but not everything. It is a part of it. But in the industry is extremely in demand. And demand is going up or increasing exponentially because we have the database and we have the data mining almost everywhere now. So the application here is extremely important, but I think it's 40% of the artificial intelligence. It's not everything.
Okay, thank you. And yeah, we received another question from Oleg Iskra. It's a very long question, so I'm going to read the description. So he says there are a lot of software libraries or frameworks for studies or research in machine learning which have been created during last years. But in the hardware section, we can find only a few examples of specific processes for processing digital data and machine learning. What is the most significant research in this area over last years? Like maybe the most significant accomplishments, right? The most significant studies in this area over the last years. And the next part of the question, what is slowing down these studies?
Yeah, exactly. Yeah. So the slowing down of this study, I think the complexity of some tasks. So sometimes it's extremely complex and we cannot reach high accuracy. Just to give you an example about the cancer. If you are not able to build a system with high accuracy, 99%, 100%, you will lose the trust of the radiologist. So the radiologist will never use your system. So the material exists in the research, the material exists, but the radiologist cannot use it because there is a lack of trust between the two. So in order to, in this, some application is really sensitive. You have to do some machine learning which is extremely perfect, but it is a little bit less, will be never implemented in the real life. So this is extremely sensitive. It's up to the application, up to the countries, and up to the industry too. So it's extremely, for example, if you do the banking and you want to estimate something, so if your system is not reliable enough, it will never ever be implemented.
Okay, thanks, Professor.
Yes. Thanks.
So I think the next question is for me. It's about posting Q&A on Facebook, in DK. Yeah, sure, we can do it. We'll post all the questions with the answers on Facebook. So it was from Dmitry Kustersky. The next question is about artificial neural networks. Well, Marat Valiyev asks if there will be a study group on artificial neural networks at Innopolis University. Can we do it? Can you do it?
Yeah, of course. Definitely. Yeah, definitely. And the presentation of today is look like the artificial intelligence is how to get the weight W in order to optimize your function F. Yes, extremely. Yes, of course. Yeah, we can use it. We can use hybrid method, hybrid classification with different methods, different algorithms in order to come out with the most optimal approaches for machine learning. Yes, definitely, of course. So the course at the end will be designed and will be typed by the students. So later on, it's up to the student interest. My research, my topic, my courses will be oriented to, of course.
Okay, thank you. So another question is about machine learning again. So what is the most problematic bottleneck or problematic thing in the machine learning concept? Is it a technical component or a theoretical one?
I think the both. I think honestly it's both, but most is theoretically part. So why we need to do some mathematical background, mathematical model in order to get all the benefits and analyzing and understanding all those algorithms and to improve them, of course.
Okay, thanks. So there are no more questions. Okay, and another one. So from Maxim Kazakov, he's very active today. What tasks do students solve during their studies? Well, it's a question about the course. What tasks will students solve, will students do during the course? During your
Exactly, as I said, so my course will be typed and will be designed according to the interest of my students. So if you are interested to some topics, if you are interested in some approaches, so I will focus on it, of course. And if there is two different opinions or two different approaches, so we can split our class to 2 or 3 groups, and each group can work on one side and on the other side, and later on we can do all the presentation together and to share our knowledge and to improve our methods as research, of course. Yeah.
Okay, thank you. Professor, maybe you could expand a little bit on the projects the students will be involved in during your course.
Yeah, of course, yeah, exactly. Yeah, of course. Yeah.
Okay, different. Okay, and another question. So, from Mansour Hazeev, I have heard a lot about different universities making artificial intelligence. According to you, they have succeeded only in programming robots and computer to generalize data. Is it possible to teach machines to make decisions, making conclusions in the future? So it's like almost like humans, make them have some human abilities, like decision-making abilities.
Yes, I think maybe we can reach it. Maybe we can be very close to it, but I think we need a lot of work, a lot of multi-discipline, multi-groups, multi-leaders to work on it. Yeah, but I think we can be closer to it. To be exactly as human, to be honest with you, I don't believe on that because it's extremely complex. And to be closer to it, maybe.
Okay, thanks a lot. So, no more questions so far? Yeah, we still have a few minutes to answer your questions, so please go ahead. Send them to us. Okay, so if you don't have any questions, then I'd like to mention the following thing, that the next webinar is scheduled for March 11th, or we'll talk about theory of computation. And I encourage you to register for that webinar. It's going to be very interesting and informative. And well, I also told you that the author of the best question will receive a special gift from Innopolis University. So we'll make a decision within the next few days, and the winners will be notified by email. And if you have any questions or recommendations, anything, you may send everything to the following email address. I'm typing it at the moment. It's webinar@innopolis.edu.ru. So, right? And yeah, I will send answers, and well, I may also share the presentation with you if you want to, because there were a couple of questions about the presentation, right, and about the list of literature, of books you should read on machine learning. So, okay, no more questions. I think that's it. So, Professor Belhauari, first of all, I would like to thank you for a very interesting presentation and for answering all the questions. And dear attendees, thank you very much for joining this webinar tonight. I hope you liked it. So, and I would be happy to see you at our next webinar. And if you have any questions, just let me know via email, right? So I wish you a very good rest of the day. And thanks again, Professor Belhauari. Oh, and one more question. Okay, before we say goodbye.
Yes.
So it's not a scientific question, as Mansour says. Every human has a right to make a mistake. Like, as Mansour writes, has a right for a fault. What about computers?
Exactly, yeah. So we need to be in the computer that the computer will learn from his mistakes. Exactly, yeah. And this will be a dynamic learning process for our machine learning, yeah. Of course.
Okay, thanks a lot. Well, I think that's all the time we have. So have a good rest of the day, and goodbye, everyone. Thanks, everybody.
Thank you. Bye-bye. Very
Bye-bye.
most welcome. Bye-bye.
Bye.
Bye.